Okay, welcome to this video on handling numbers in science. This is going to look at how to use the appropriate amount of digits and how to properly represent numbers when they're given to us in science questions. So we're going to start with what to round to. Some questions won't always say how many digits you're supposed to be rounded to in your answer. It won't say like this many digits or to this many decimal places. And we need to figure out how accurately we are allowed to represent our number based off the measurements that took place in the question. So this is about accurately representing those measurements that were involved. So adding and subtracting, if we're adding or subtracting measured numbers, we're going to round to the least number of decimal places. If we put any more than that, our answer would be saying that it's more accurate than we actually know based off those measuring devices. Multiplying and dividing is going to be the least number of significant digits, and that'll come up after we do a couple examples here. So the first one is 5.2 plus 6. So what this means, if we measured something, say 5.2 centimeters, and we measure something else to be 6, that 6 is only a whole number. It doesn't say that that's 6.0, so we only know it accurately to that one value, all right? So that one whole number. So that could be a 6.1 or that could be a 5.9 that got rounded up. So I don't know that one very accurately, so I only know this to the nearest whole number. That means looking at here is that I can only represent my answer to the same accuracy I have in my question. So 5.2 plus 6 in your calculator would give you 11.2. But because we didn't know what that decimal place is, we can't represent the decimal place in our answer. So we need to round to the nearest whole number as it says above. So 11.2 would round to 11, and that's how we'd write our final answer. Looking at the next one, 0.14 plus 4.6. The 4.6 we know to one decimal place, and the 1.4 we know to two decimal places. We need to go to the least number, so we're going to round our answer to one decimal place. If you add those in your calculator, we get 4.74. And so we have to round that to one decimal place, and we get 4.7 as our answer. Okay, and the last one, 100 minus 4.8. When you put that in your calculator, you get 95.2. We'll look back in the question. There was one decimal place here, no decimal places there. That's just the nearest whole number, so we'll round to that, which is 95 for our answer. Okay, those are the rules for adding and subtracting. Now we'll take a look at significant digits, as that's how we're going to know how to round the multiplying and dividing. So significant digits, all numbers in a value are going to be significant except for the leading zeros. Those are just placeholders, so we won't count those in the accuracy of a number. So examples just for determining significant digits here. 13, those aren't zeros, there's no leading zeros. There's two digits there, and we have two significant digits. 102, zeros are only insignificant if they're leading. This is in between two non-zero numbers, so all of those count, and there's three significant digits there. 0.34, this is the first time we have a digit that is considered not significant. 3 and 4 are good, but this is what's considered that leading zero. All right, so that one doesn't count, and we only have two significant digits here. It's just saying that we have 34 hundredths is what the zero means. Okay, on to the next one. We see there's two leading zeros off the start, so those don't count. The 2 counts, this 0 is in between two non-zero numbers, so it's not leading. And the 3 counts, we have 3 significant digits there. All right, so now we'll do some examples where we actually have the rounding to our least number of significant digits, like it said up here for our rule for multiplying and dividing. We have to go to the least number of significant digits. Okay, so let's scroll down to those, and we're going to start with 2.4 times 3. So that's again something you measured to 2.4. The other thing we measured, we only knew to a nearest whole number of 3. So when you type that into your calculator, you get the answer of 7.2. But now we're going to round to the least number of significant digits. 2.4 has 2 significant digits, but 3 only has 1. So we need to round to only one significant digit. So we're going to take the 7.2 and we're going to round it to 7. Again, it's because we don't know what comes after that 3. This could have been 3.1, could have been 2.9, 2.8, so we can't represent our answer with more significant digits than we had in the question. Okay, let's go to our next one where we have 145 divided by 5.6. And I'm getting a really long number here. Let's write a couple of the digits down. 25.892.857. And it actually keeps going a little bit longer than that. So really, really long number. I don't want to write that whole thing, but how many digits do I write? Well, we look in our question. I have 3 significant digits there, 2 there. I need to go to the lowest number, so I need to round to 2 significant digits. So I'm going to put the 2 and the 5, but I do have to check to see if that 5 is going to round up to a 6. So I look over to the 8. Since it's greater than 5 or greater, I am going to round it up to 26. And that's the final answer there. So same significant digits in our answer as we have in our question. This next one, 0.27 divided by 0.05, an answer of 5.4. All right, look in our question. This 0 doesn't count. There's 2 digits there. These zeros both don't count. There's only 1 digit there. So I only need 1 digit in my answer, 1 significant digit. So this 5.4 is going to round to 5. Okay, hopefully you're feeling comfortable with that. That's going to deal with a lot of questions that are with relatively small numbers. But if we ever have any bigger ones that's dealing with like the thousands or really small numbers in the thousandths and things like that, or much bigger or much smaller, we have to use scientific notation. Okay, it's used to represent very big or very small numbers. So if you took like the distance from the Earth to the Sun in meters, it's a really, really big number, and we don't want to have to write that out every single time, so we have a way to shorten that up. How we're going to do this is we're going to take the decimal place and move it to the ones position. Always to the ones position. Sometimes I see people moving it, but they move it to like the tens or hundreds position. Always to the one spot. After we've moved it there, we can round to however many significant digits we need, and then we place times 10 afterwards, and then we have to put an exponent on the 10 to however many decimal places we moved that decimal. All right, we'll show that in an example. Then lastly, on the exponent, you put a positive if it's a value greater than 1, so a really big number, and you put a negative exponent if the number is less than 1. Okay, so we'll just do 2 examples here. So if we take 180 and we times it by 30, your calculator is going to show you 5,400. Okay, and that's all good. That's the correct value your calculator is showing you. But how do we round this number? Well, since it's being multiplied, we look at the question and there's 1, 2, 3 significant digits there, and there's 1, 2 significant digits there. So we need to round to our lowest number of significant digits, which is 2. But if I take 5,400 and I just write 54, that's smaller than the number that we had at the start. So I can't write my 2 digits like that. So if we can't write our number to correct significant digits based off its size, we need to then use a scientific notation. So following these steps with the decimal place being moved to the ones position is our first step. It started right here. That's where the decimal would have been. And I'm going to count how many spaces I need to move it over to get to the one spot. So I have to move it 1, 2, 3 positions. Now I'm going to write it as 5.400, just copying the same numbers we had before. Now that this is a decimal, I can round that to significant digits I need. I only need to keep 2, so this would round to 5.4. All right. The next step, though, is this number wasn't 5.4, so to indicate that it's bigger than that, I need to write times 10 afterwards to the exponent of how many places it moved. And again, it moved 1, 2, 3 spots, times 10 to the 3. If the value is greater than 1, we put a positive, so we're going to leave it positive. So the answer for that is 5.4 times 10 to the 3. Trying the division one now, we have 0.45 divided by 850. This gives you a really small number. If we put in our calculator, we get 0.000529412, and it keeps going on and on. So it's a really big number. It's a really small value, but a really long number. And we don't want to write it the whole thing out, and we have to figure out how accurate we should represent this number. Well, since it's dividing, we have to look at significant digits in the question. There are 2 here. That leading 0 doesn't count. And there are 3 here. we have to round to the lowest number of significant digits in our question, which is going to be 2. Now, you could represent this like 0.00053. That 9 would round up that 2, because all of these zeros don't actually count. So that would fit your amount of significant digits, but it's just really long to write all those zeros. So we can turn this into scientific notation, really similar to what we did before, just the opposite direction. So I'm going to move that decimal so that I have 5.3. So I'm putting it into the ones position. 1, 2, 3, 4. All right, so now I have a number of 5.3. Moved it so 5 is in the ones position. Good. Now I'm going to write how many places I moved it. So times 10 to the, again, I went 1, 2, 3, 4. And then last, you have to look at the sign. As it showed here, we're going to put a negative exponent if the value is less than 1, which it is. This original number was much lower than 1, so I'm putting that -4. And that's the final answer, 5.3 times 10 to the -4. So I hope that's given you a bit of review on how to handle the numbers in all of these science questions you're getting. Let me know if you have any questions, and I'll see you in the next video.